Hello, everybody. Welcome to the Eonics Podcast, a podcast about software development, alternative employment types, and many more interesting things. Today, I am talking to Amir. Amir recently did a hack night with us with a very interesting topic, being reactive programming. So, welcome, Amir.
Hello.
Great to have you on today.
Thanks for inviting me. I'm very happy and excited to be here.
Well, that's very good. I was also very happy and excited to listen to you on the hack night. It was so very interesting. So let's discuss that for a little bit before we dive into the depths of reactive programming. So to me, the storyline of your hack night was that you actually took us back into the past of where reactive programming started.
Yes.
And every time that something new was introduced, you actually told us, okay, so we did that, but it sucked because ABC. And then we stepped into the next thing. And to me, that was very interesting because, well, it was, every time that you looked at it, it was like, oh yeah, okay, I've seen that. Oh, so those are the drawbacks. So now we can actually address those drawbacks with the next step. And in the end, we ended up with Project Loom, which was like the holy grail of reactive programming today. But can you maybe tell us why you took this approach? Why is it important to take a look at the history of reactive programming?
Yes, like in Dutch, natuurlijk.
Thank you.
Yes, as you mentioned, during the hack night, we had like a journey from the old days in Java all the way to the recent release of JDK Project Loom.
Yeah.
And there was the reasons that I was thinking how that I decided to arrange the presentation in this way. And I can mention at least two major reasons. So the first one is that when we talk about technology, of course, when it comes to software development, I believe it's very important to understand the history.
Yeah.
And when you know the history, basically you understand it with all the details more deep, and that would prevent like errors and mistakes when you are using the new technologies.
Yeah.
I can explain it with like an example. I think most Java developers, they know a Spring Framework, and originally Spring Framework was introduced as a dependency injection or inversion of control. And but if you as a developer, if you start writing Java code using a Spring today, you just inject the beans and you don't know, okay, what's happening.
No, exactly.
But if you understand what was the pain, basically if you feel the pain, and then you can basically have a better view and write a better code.
No, exactly. Yeah, I think that maybe actually one of the problems today with software development, right? Because we have so many high-level frameworks that new developers are probably struggling to understand. So what's going on under the hood, right? So if everything goes well, you're good. But if it doesn't go well anymore, then probably you're lost.
Precis. And that's the second reason that I arranged the whole presentation in a historical journey was that about keywords. So if you look at reactive programming, there are quite a few keywords that they can be used instead of each other. And when you see different frameworks, different technologies, when you understand their terminology, basically you're not lost when you read the document.
Exactly. No, that's very important because indeed around reactive programming there's so many words and it's like, okay, that's what you mean.
Observables, events, observator, and all these kind of things.
All right. So one of the things that I feel that is very important to take a look at is why do reactive programming at all? Right, so I think that if you're taking a look at like a default project at one of our clients, I don't think that many of them are doing reactive style backend work, probably because it is a bit more complicated. But can you tell us why it would be a good plan to do so?
Yes, of course. So when we look at like projects, of course you're right. So there are many projects that is written in a blocking way.
Yeah.
And I will go with like Spring examples because that is one of the most common frameworks in the
I think 90+% of the projects that we're doing is supported by Spring.
Spring. So if you write an application using a Spring classic Spring MVC, I call it classic now.
Yeah.
Yes. But if you write an application with a Spring MVC, that it is a fact that for every coming request you will assign a thread, a dedicated thread, and if this thread is blocked by any reason, then you don't have this thread until it is released again.
And there are many reasons for it to block, right? So if you're doing a database request, it will block until there's an answer.
Exactly. Any kind of I/O is a blocking. Any kind of like another REST call. So you only need to read a configuration from other server, but if it is slow, then you're blocked.
Yeah, exactly.
And the number of threads in a JVM application is limited. So I have an example. I had a friend and a long time ago, and he created an application using a Spring and Tomcat.
Yeah.
But he used everything was working fine in a testing environment. But he used this to for a gaming application.
Okay.
And then he was saying the moment that we start application, it was going down after 2-3 minutes because of number of requests coming through. So.
It was too high,
yes.
So the new request could not be handled because there was no thread.
Yes, exactly.
Okay, yeah.
So then we have this new world of reactive programming, and in a Spring world, of course, we have Project Reactor, mainly contributed by Spring developers.
Yeah.
During the presentation, we talk about a lot of them, but Project Reactor is like a Spring way of doing reactive programming. And then basically this problem is solved.
Okay. So can you take me along into how that works on a bit more detailed level? So suppose that, let's say we're implementing an API call, right? That is actually taking some data from a database.
Yes.
Like I think that is the most common use case. Suppose that I want to have a list of all, I don't know, bank accounts or something like that, right? Suppose I want, give me my 10 bank accounts.
Yes.
So how does that work exactly with the Project Reactor?
Actually, you mentioned a very good example. So when we create such an application, so with a reactive framework, Spring in this case. So we have a incoming request, and then we have this concept of worker threads. So worker threads is kind of a thread pool, but in a different way. So when they go to they call database to retrieve some data. If it is going to take a long time, then they release this thread, basically. So it's not going to be blocked, and they distribute this work among these worker threads. And then when it is ready, another worker thread could be selected to continue this, but it will have the same context of execution. So
to me, reactive programming, the first time I ran into that was on the front end, because everything on the front end is typically reactive these days, right? So if you're doing Angular or React or Vue or whatever, all of these frameworks are, reactive in a way. It's at the very least asynchronous.
Yep.
So you're doing an HTTP call, and then you have a callback handler.
Yes.
And depending on the Angular version, it's like a promise or an observable or something like that. But basically what it says is, when you're done with your action, do this.
Yes.
Right? So have a function or something else to be called. Is that also how it works on the back end? Suppose that I do a database call. It's like, here's the database call. When you're done, call this function.
Exactly, but it will be handled by framework, so you don't have like a view of these low-level handling things. But if you can say it, yes.
But from the code perspective, is the code also arranged like that? So do you need to create like a callback method or an observable or a promise, or is the if you write the code, can you just do it in a traditional style, and is it like all of the reactive stuff is on the hood?
if you ask about Project Reactor specifically, that's not the case. So that they have a completely different syntax of writing code.
Yeah.
But
on every level, then. So
yes.
If you're supposed that you're doing, let's say we're using JPA and Hibernate to talk to the database, right? You cannot just say, okay, use an entity manager or something to do that.
Exactly. You actually mentioned another good point when you, that's a very important thing to consider when you are writing your application using reactive libraries. The whole stack should be reactive.
Yeah.
So that's why you mentioned about JPA, and then we cannot use JDBC, or there is another driver called R2DBC.
Okay.
So it returns the return types of these R2DBC are monos and flux.
But is that because like JPA, JDBC is like way under the hood, right? So you're not doing any JDBC when you're doing JPA. Can you use JPA and then say, okay, as an ORM tool or JDBC implementation, I want to use that
Yes,
R2DBC?
they have another abstraction on top of R2DBC in a Spring Boot, of course.
Okay, yeah.
So when you build your application using Webflux, and then if you add the dependency of the R2DBC, you have a JPA way of doing the database calls.
Okay, so it does look like that. It's just that the way that you call that is looking quite differently from a normal style.
Yeah. And then when of course when a method returns a mono of flux, it's not suggested, and you should not do like get these IDs from database and okay, I'm gonna save it in a variable and do something. No, it should be all in a pipelines.
Yeah, exactly. So yeah. Okay, so it sounds to me like, okay, the plus side is that you don't have any blocking threads. So basically you can scale up. Well, obviously there's some limit to your upscaling, but you're not limited by the number of actual threads.
Exactly.
The drawback is that you probably need to learn an entirely new way of handling code, right? So you need to do it differently than you're doing it today.
It doesn't look like a classic Java programming.
No, I think to me, Spring Boot, well, the upside is that it's so very simple, right? You've got a controller, then you have a service calls repository, does some database magic, which is mostly under the hood. Then you get some result, you pass it back to the controller, you probably do some mapping, and then you give it back to the client. Whoever is the client. But that doesn't work like that with Webflux. With Project Reactor and Webflux.
The high-level structure is more or less like that, but so the whole code, for example, in your controller to service, so service is receiving something from controller and should return something, but you don't have this freedom of writing imperative code.
No,
like
exactly.
Store this variable, compare, and so everything needs to be handled in a way of pipeline things.
Yeah.
And then I can give an example of one difficulties. So when you have these pipelines, like a set of operators that you're applying on an input, and what if you want to have an operator on two inputs? Yeah,
exactly.
So one thing is passing around from A to B and B to C, but what if you need two things? And I remember that we found a way of doing this is like a trick to you have to extract a method. So you use the method parameters all the way in your pipeline to pass something.
Yeah, but it does sound like a trick.
Yes.
And that probably, I think it hurts debuggability and readability, right? So if there's a new developer, probably takes quite a bit longer to get accustomed to this way of working.
For me, it did.
Yeah. And you're such a smart guy. All right.
I'm not.
Oh, yes, you are. But do you feel that there's a solution to that issue?
It's actually according to the journey that we went through together. So after Project Reactor and Reactive X, now the new demand was, what if I want to write my regular code and I want it to be reactive under the hood? So why should I write this weird way of writing code? And then the answer would be Kotlin coroutines or recently Project Loom.
Okay, so yeah, Project Loom, I think that was part of JDK 21,
Yes.
which is very new. So not many clients are already using that. So suppose that you're still on 17 or maybe even 11, I don't know. Can you use Kotlin coroutines with Java 11?
I think so.
Okay,
Yes.
so that's good. So suppose that you're on 11 or 17. That's like, I think for most companies that's the case, right? So can you explain to me how that would work with Kotlin coroutines?
So basically, Kotlin, if I want to go through it quickly, Kotlin introduced this concept of coroutines, which are the lightweight threads, and they are not handled by OS. They are like introduced by JVM in the JVM level.
Okay.
And so they are not like heavyweight, and blocking them is not that costly.
Okay.
So that's why when we block them, we call it suspend.
Okay.
So it's not like a very heavy thing to do in a Kotlin, and then we can have millions of coroutines. So you can write your regular code, and then just considering some rules, then you can make sure that your code is able to handle loads.
But I think a coroutine, it very much looks like a function, right? It's just a function call, or what does it look like code-wise?
Code-wise, I think you have to mark it. Yeah, basically, they have this concept of scopes, and if you want to enter this coroutine area, you have to add a keyword on front of your function, or you have to start a block saying that this is the coroutine scope.
So basically, it's like the equivalent of saying this is an asynchronous function, like that.
Yes.
Yeah, exactly. But the rest of the function stays the same. So you do have your parameters, you have imperative style programming, and you just return some value. And the only difference is that it's handled asynchronously. Yes,
basically you write your imperative code, and if it is going to be blocked, basically who cares? Just let it block, and so it's
because it is actually, it's not blocking the thread, it's actually
suspending the coroutine.
Yeah. Okay. That sounds very cool. It's just that, well, you need to do Kotlin, right? So not everybody can do that, I suppose. Well, maybe everybody should do it, but
I think Android developers love.
Yeah, I think that it's getting more and more common, right? So, well, if I take a look at the clients that we've got, more and more of them are actually switching to Kotlin on the back end, which is great because I feel that the language is it's a lot prettier than Java. That's also because it's new and they can do many changes on it.
They can do whatever they want.
Yeah, that is the big difference, right? Yes. So with Java, it's like, it's old, it's bloated, it needs to be backwards compatible and stuff like that. So I think that is one of the advantages of Kotlin. They're young and they can make changes.
Yes.
All right. So let's briefly, maybe a little bit longer, dive into the Project Loom for those people that are actually already able to use JDK 21. Can you explain to me what Project Loom brings? What was the purpose of it, and how does it do that?
Yes, actually, Project Loom. In Project Loom, they introduced a concept very similar to Kotlin coroutine. It's called virtual threads.
Yeah,
and again, it's like lightweight threads that they are handled by JVM. So they can be suspend, they can be resume, and
this is part of the JVM, right? So it's not some layer on top, it's just JVM thing.
Yes, it's you basically write Java code, and there is a very famous example of proving this. You can find it by googling it. Basically, there is a Spring MVC application using Java less than 21, and then you put it under load, and then it will crash after some certain of load, and then you don't need to change the code. You only change the JDK, and boom,
it works.
Yes.
Yeah.
So that's the beauty of Project Loom, because it's like feature of the JDK.
Yeah. So if I understand correctly, a thread becomes a virtual thread. So old style, traditionally, when you're handling a request and it's being blocked, for example, because you're doing a slow database call, it's actually blocking the thread. In the new situation, you're not on a thread, you're on a virtual thread. So it's basically suspending that virtual thread. And that doesn't mean anything. The underlying actual OS thread can just continue.
Yes, exactly.
So you can do imperative style Java programming, and under the hood, you're doing all kind of magical asynchronous stuff.
Yes, and we can say that you are not your application is not fully blocked because of some request waiting for data coming from database, or waiting for data coming from other other microservices, basically.
Yeah,
and there is okay.
It sounds magical. I actually saw, well, apart from your presentation, I think we went to the J Spring together, and we saw that other presentation, which actually to me was the first time that I saw it, and it was wow, it was magical.
Yes.
But do you feel that the thing that we talked about at the beginning, right? So because we have all these high level frameworks that abstracting all the complicated core functionalities, don't you think that this is one of those things that also going to impact the work of a developer? So you think you're doing synchronous style programming, but actually you're doing asynchronous style programming in the in the JVM. So do you feel that this would impact debuggability?
Goeie vraag.
Yes.
Actually, I think since it's being handled by JVM itself, I think they have like I suppose they have like a very good isolation of this concept of context of threads, virtual threads. It might be a bit complex. A bit more complex to debug, but I think compared to the previous solutions, I think it's better.
Yeah, exactly. So there may be some corner cases where there's some fake situation, and it's because of you're using virtual thread. But what you say, and I think I do agree, is that because it is part of the JVM, it is so thoroughly tested and stuff like that, the chances of having an issue because of that are way lower than having some vague situation with Project Reactor. All right. Can you also tell me what will happen if you use JDK 21 in conjunction with Kotlin coroutines? Would it add any benefits?
I think that would be like a mix of everything. So you have the lovely coroutines, and then the coroutines itself, they are being run on virtual threads.
Yeah, exactly. So there's no chance of blocking anything.
No, I think no blocking. And I think for the answer to this question, it depends on the current situation of the project, I think. So if a project is using, for example, Kotlin coroutines, if they switch to JDK 21, I think they just get some more efficiency. So
so maybe I think to me the benefit would also be that it's a bit more explicit that you're doing asynchronous code, right? So with Kotlin coroutines, you have to mark something as being asynchronous, which to me, I think it's always nice if things are transparent.
Exactly.
Instead of being hidden somewhere, right? Somewhere something magical is happening. Instead of that, you need to mark something.
Yes.
I think that would be a different situation, and probably because with coroutines, your code is probably already optimized to be used in an asynchronous fashion. It's probably faster than just putting any old style Spring project on top of Project Loom.
Yes, and one more difference that I would like to mention is that they call it, some people call it forward compatibility about Project Loom.
Yeah.
So when you use even Project Reactor or Kotlin coroutines, you have to make sure that you don't use, in your whole stack, you don't use classic Java blocking APIs.
Yeah.
Why? Because you have this concept of worker threads or coroutines, but there should be one thread that is scheduling or managing these lightweight or worker threads. And if you use one of these classic blocking APIs, and then it might be the case that you are blocking that manager thread or that scheduler thread, then nobody is going to wake up the coroutines or the worker threads.
So you're talking about things like java.io or something like that.
Yes, exactly. So it could be that you are blocking that main guy, and then
you're blocking the main guy, and you're fucked.
Yes, we can say that. But in the Project Loom, JDK 21, they retrofit they are working on JDK, they can do. So this is the advantage of having this in JDK. They are retrofit or rewriting the classic blocking APIs in a way that you can imagine. It's also in the presentation. You can imagine a code is not like this, but if a thread is a virtual thread, then do not block, suspend. So that's the beauty of forward compatibility. So you're free to use classic.
Yeah, okay. So that you don't have to consider anything. And well, if you've forgotten at one place to use the latest and greatest APIs, then you're still not being shut down.
Yes.
Okay.
There are some very small exceptions, like this Java. In Java, there is a synchronize keyword when you open.
Yeah.
I don't think nobody is using that anymore. But if there is a library that is using that guy, I think that there might be some problems there.
Okay. So don't use synchronize.
Synchronize. Ever. I don't. I can't remember the last time that I see this keyword.
Yeah, it was a long time ago when we still had race conditions and stuff like that. So that was great. Okay, man. So we've already been talking for quite some time. So I think we should wrap it up. Any last words, great advice that you want to add?
Thanks a lot for inviting me.
Those are your last famous words. That's good. Thanks for being on. So if you want to see that wonderful presentation that Amir did at the Hack Night, and you should want to do that because it's really great, you can actually check it out. It is posted along this podcast. If you want to see more of this podcast, please become a subscriber, and we can actually see you there. And for now, thank you very much, and see you next time.
See you.
Bye.
Bye.